What is going on, guys? Welcome back. In today's video we'll be doing a problem submitted to me by a viewer. If you guys want me to do a specific problem for you guys, feel free to send me the details through Instagram YT_TheSwissArmyTutor. It'll be in the description below, where you can interact with me, send me topics for future videos, and even send me videos which may or may not be used. So today's problem is show that triangle LMN is similar to triangle PNQ. This is a geometry proof. It's your very first introduction to proof, usually using two column proofs. Alright. And we're usually given some sort of information to help us do this, and then we use every single possible property of geometry that we know to show that these are similar. So there are three postulates that we have to show a similarity. There is AA, and what this is angle. We have side, which is third one is side, angle, side. Angle. So if there's two angles that are successive, if there's two angles that are next to each other between two sides. Alright, so if we have two angles that are next to each other in both of the triangles, then by angle postulate, they are actually similar. Now, side says that if all three sides of the triangle are congruent to all three sides of this triangle, therefore they're similar. Alright, they're similar by side. And in fact, that's actually another postulate that slides over to congruence. Now, we're not given any sort of congruence for that, so we can't really say that. And then we have side, angle, side. So we're going to do some red real quick just to demonstrate. So angle. So if we say for side, angle, side, if we have two congruent sides, side, and we have angle and we have side, in both triangles that are congruent, therefore they're similar by side, angle, side, and these two actually slide over to congruence. These are actually congruence postulates as well. Angle, if we have two consecutive angles, they are similar by angle, and side, if all three sides are congruent in both triangles, well, that means that they are congruent by. Let's back it up a little bit and go back to the problem at hand. So this is actually taught in early geometry. It's within the first couple weeks of your high school geometry course. So we're given that side LM right here and side PQ, they're parallel to each other, which is what these arrows mean. Typically in some books you'll see them with two arrows signifying that they're parallel. Some books you'll see one. It just really depends on the mathematician. This should be right here should be N. I'm so sorry about that. So there's a couple things you guys notice in the figure. So we have parallel lines, but if you notice, this triangle and this triangle, I know they don't look like triangles, but they share a common angle. This angle, this N. And so we say that these are vertical angles. These are congruent by vertical angles. Why are they vertical? Well, it's because they share the same side. And going through the proof of that's actually kind of complicated. So if two triangles share a common point, if two figures share a common point, the angle between both figures will be congruent, because they're sharing that common point, that angle. So that's a vertical angle. Now, what's going to happen now is, well, a lot of time we get cocky and we're like, this is easy now. We have one angle, but we need either another angle within a triangle, three sides, or two congruent sides as well. So you guys are probably thinking, we're not given much more. What else can we do? Well, with that, we could then use the fact that LM and PQ are parallel. When you see parallel, you'll see in books as well these double lines signifying that they're parallel. And so what's going to happen is between these two angles, we're going to forget about everything here. So we're going to redraw LM, and we're going to have PQ. With parallel lines, we get a line that intersects them, called a transversal. We can start showing a bunch of different quantities. So, if you guys notice, this line, so if we were to extend this out, sorry for my shaky hands and terrible writing on a computer. This is easier to do on paper, honestly. But so if we extend this out, you'll see if we take side LM and side PQ and we extend them out, you'll see that side LQ, if we were to extend it out, will cross these with this this is what we call a transversal. And with it, we are able to actually show a bunch of different congruences of angles. So we already know that these angles here are congruent, and we could also say, let's grab another color, this angle here and this angle here are congruent. Why is that? It's called alternate interior angles. So what's going to happen is, so like I said, this and this are congruent by alternate interior if there's a transversal, and we can do the same with these here. We already know that because of vertical angles, these are congruent. We already know these are congruent in here. And the same idea. So these are congruent by alternate interior angles. So we have two angles and two angles that are congruent. Therefore, they are similar by angle-angle postulates. Now, the hard part of this is writing it up. So, using a two-column proof is we're going to write our claim, and then we have reason. So, the first thing we can say is side LM is parallel to side PQ, and the reason we state will be given. And we also, our next thing that we said was angle. So it's not enough just to say angle N when we're writing it up. The reason being is because there's an infinite number of angle N's. So what we could say is LMN. So LNM. So because n's in the center, so let me write this out. Angle LNM is equal to angle PNQ. Because n is in the center, that's the angle we're focusing on. And we say that they're given by vertical angles. And so our last one was angle NM. Angle NLM is congruent to angle NQP by alternate interior angles. And then with this, we could say triangle LNM is similar to triangle PNQ by AA. Angle-angle postulate. Alright, and that's how you write it up.